Hello there. Today we'll be doing number 150. This will be completing the 150 neat codes, at which point we will be doing a series of videos on the 150 neat codes one more time, but this time we'll be doing neat codes in terms of topics first. We'll do all the problems all the way down, and we'll come up with some concepts, and we'll do a review at the end for each topic. So that's going to come up very soon, but let's finish up this one problem first before we get to that point. So in this problem, it's called minimum intervals to include each query. So in this particular problem, we are given a intervals, and given queries. So what we're trying to do is make sure to find the shortest interval for each query. So for query 2, the distance between 4 and 2 is 3, 4 and 1 is 4, and so by distance we mean 1, 2, 3, 4, and you have 2, 3, 4. And then we have 3, 4, 5, 6, and we have 4 and 4. Those are our intervals, and we're going to take our query of 2, 3, 4, and 5 to be checked and see which interval it fits in, where it's the shortest. So the 2 fits in this interval where it's the shortest, which means it's going to be give us a result of 3. The 3 is going to fit in this interval as well. It fits in these 3, but this one's the shortest one, so it's 3. 4 fits in all 4 intervals, but the 4th one is the shortest, so it's going to be a 1. And the 5 only fits in a single interval, which is this one, and that's going to return us a 4, which gives us this particular output. Thing is, this particular process will result in a length of O of length the intervals times the length of the queries, n times m. So that's quite slow for this particular problem. We can speed this up if we do some sorting. If suppose we make sure that we take all the intervals and add that is less than q, and add them where the left of the interval is less than q, and then we add them to a min heap, we can pull those out later and find the one that is the shortest. And that way, we also remove them once the right is less than the q, and less than our query, and that way we have the minimum item in our min heap. If there's nothing in the min heap, there's no interval exists, we'll return -1, and that way we can solve this problem in log n, n log n and m log n time, which is basically because we're sorting the intervals and sorting the queries. Okay, let's just get to it, and let's go to the code. So first things first, let's make a min heap, and we're gonna store the distance and the max, the right end of the query. That this the distance is for results, and right end of interval. This right end of interval is for removal. Okay, and we need results. I'm going to use a dictionary for that, and we're going to use a I equals 0. So for one thing we haven't done is we haven't sorted our intervals yet. So intervals, that needs to be sorted. Sort. We also need to sort our queries. The reason why we need to sort these is because if suppose we don't want to add things that are not within bounds yet, and add things that are out of bounds at the same time. What I mean by that is, suppose we had that earlier example, and we had this 1, 2, 3, 4, 5, and 4, and 5, and 6. We don't want to add a, we don't want to check for 6 first and then check for 2. Because with that check, we'll skip this one, and we will not have that in our query, and we would not find an item for 2. So we have to swap it around. One more thing is that the reason why we're using a dictionary is because we want to swap everything back in order. We want to keep everything in our query in order. That's why we're using a dictionary to put everything back in place. Okay, very good. And so let's just get back to the coding now. So we're going to put all inbound intervals into the min heap. And once we have all the inbound intervals, we'll select the smallest distance. To put all the inbounds, we need to make sure we insert all intervals where left bound is less than q, our query, and remove all intervals where right bound is less than query. Okay, so let's get this. So to put all the items into the min heap, we're going to do a while loop. While I is less than the length of intervals, and the left bound is less than the query. So basically, interval at I and the left bound, which is 0, is less than the query. Less than or equal to the query. Because as long as it's within the query, we should add it to our min heap. So here we go. Left and right is equal to the intervals of I, and heap q dot heap push min heap, and we're gonna throw in the distance, and we're gonna put in the right bound, I plus equals 1. So that completes our first objective of inserting all items. And now we need to remove the items that are without a bound. So while min heap and min heap at a 0 and the right bound 1 is less than q. So if this particular item is less than q, that means q is greater than it. It's no longer within bounds. So we need to just pop this item out. And with that done, we can select the smallest distance. So results at q is equal to the min heap at 0, well, 0, which is the distance. We should just set this as distance, smallest distance. And with the smallest distance, well, we need to know that if min heap, then we're going to insert this, else, whoops, we need to insert, if there's nothing in relevance, we need to return a -1. So that's the smallest distance, and let's record that in our queue. So smallest distance. And with that, I think we have better wording and everything to make sure that we don't make any mistakes. Or in the future when we do read, there are comments available. Inbound intervals for a query. Yes, there we go. I think everything makes a little bit more sense here. Yes, everything looks good. And we have all the smallest distance. Now we just need to return a for q in queries. This is before the sorting. And what we're gonna do is result at q and make that into a list for us to return. It looks like it went out pretty well, and we have a solution, I hope, and we do. 26 milliseconds. Well, not 2,600 milliseconds, 2.6 seconds. Not too bad, not too shabby. And we have solved this particular problem. And when you see interval problem, think min heap to help find the smallest or biggest interval for that particular query. I am hoping to, explore this topic a little bit better next time when we just do solely a topic and look at the pure concepts that apply to all of the problems in this particular topic next time. So be on the lookout for that. If you enjoyed this video, like and subscribe. Thank you very much. And this is the end of the series for 150 Neetcode questions.